All right, 5.5 is rational roots. And when we're talking about rational roots, they can word it a couple of different ways. It's roots. That's the same thing as finding the solution. They may also call it finding the zeros. So it's any one of those things, but the technical definition of what we're looking at is rational roots. Now, here's the big thing you're doing in section 5, and here's kind of the question that you're going to ask, and here's what it comes down to. If you've got an equation, or you've got a function, or you've got an expression, whatever it is that they give to you, what do you do when you're not able to factor? Because everything up to now we've been able to factor something. Either we factored it with difference of perfect squares, it was the bottoms up, it was the one thing we had in last time that I don't think was on the test was if you had 4 terms, you did factor by grouping. If it wasn't one of those things, then we did the quadratic formula. The difference on this one is that quadratic formula only works if your highest power is x squared. This one we're going to have parts where we're going to start off with x to the third or x to the fourth, so quadratic formula is out, and it's nothing that you can factor. So this is kind of saying, all right, if you get a problem and you look at it and there's no way you can factor this thing, what do you do? Well, here's what we're going to do for this part. The very first thing they're going to kind of throw at you is what they call the rational root theorem. And with the rational root theorem, here's what it does. It gives you all the possible keywords, it's all the possible ones on this one. So it's more answers than what you need, but it's just all the possible real rational roots. And again, roots is just the same thing as solutions. Of the polynomial equation that you're working with. So basically this is one of those things that if you're doing a longer problem and there's nothing you can do to get this thing started off by factoring, there's no greatest common factor, there's no factor by grouping, there's no bottoms, there's nothing you can do on this thing, this is what you would wind up doing. Okay, now, and they kind of shorten this thing up, so they're going to call it P over Q. Now, we haven't talked about anything P or Q, but what they do is they tell you, all right, so we can make this thing a little bit shorter. P is going to stand for the factors of the constant term. And Q is going to be the factors of the leading coefficient. And most of the time this is going to be in standard form. If it's not, you're probably going to rewrite it in standard form anyway, and you're going to have to because eventually you're going to go back and do synthetic division. So this is keying on the first and last parts of whatever expression it is you're doing. Okay, so let's just give an example of this one. Show you what we're talking about here. Okay, so they're going to tell you, all right, just list all the possible roots. And sometimes they'll say list all the possible roots using the rational root theorem. But you're still just listing off all the possible answers that you're looking at. Okay, so we'll start with something like that. Alright, now here's the part, don't write this part of it down. But what we did before was, if we had 4 terms, again, we're going to do this on a separate paper because this is the part that you can try to see if this will work, but in most cases it's probably not going to work with 4 terms. But we said that if you had 4 terms, you could do factor by grouping. Put the first 2 terms together and the last 2 terms together and see if there was anything in common between those 2 pieces. Now, for these, again, don't write this down because I'm telling you it's not going to work, but I'm just showing you what you would try to do if you could do this. The first 2 terms, you've got x to the third and x squared. So you can take out an x squared. Take 2 of the x's out, leave you with x here. Take these 2 out, it's going to leave you with 3. Negative 10 and 4, you can divide them both by 2 or negative 2. Let's take out a negative 2 just to see what happens. You're left with a 5x, 4 divided by negative 2 would be a negative 2. Now, here's why factor by grouping doesn't work. Because if factor by grouping was going to work, these 2 things in the parentheses have to be the same, and it's not. And no matter how you say if you go back and rearrange them, there's no way you can rearrange these numbers and come back with the same thing. If it's going to be factor by grouping, usually it's going to be a sign that might be off. But for this part, there's no way you can do factor by grouping and get any of these to go. So this one's out. And somebody may be saying, well, couldn't we do the quadratic formula? Yes, if we had 3 numbers. If it was just 3x squared minus 10x plus 4, you could do quadratic formula because you've got 3 numbers. If you've got a 4th term, well, now you've got a, b, c, and d. We didn't have a d part with quadratic formula, so that won't work. So here's what we're going to do. So if we do p over q, just to list off all the factors, p is going to be the last number, and q would be the first number, and again with x to the third, then basically that's just understood to be a 1. So it's the factors of 4 over the factors of 1. Okay, and because we're trying to work this as much as we could by factoring, when we do the factoring, this is where you do it in pairs. So the factors of 4, it could be 1 times 4. I'm going to spread this out a little bit. And in the middle, it could be 2 times 2. Now, the thing about with this one set up, if you do the same number, if it's 2 times 2, you only have to write that number 1 time. And since this was a positive 4, you could do positive 1 times positive 1. You also could do negative 1 times negative 4. So we're going to say it could either be positive or negative, depending on how the signs match up. And then same thing with the 2. You could do positive 2 times positive 2, or you could do negative 2 times negative 2. Okay, and the only factors of 1, well, it's 1 times 1, so it's just, we just put a 1 there. Because we don't have to put the same 1 twice, so we'll just put, it's either 1 times 1 or it's negative 1 times negative 1. Okay, now here's where we're tying back in with the factoring part of it. If we were factoring, remember how when we had to factor, if this first term was 1, it made it easier because all we had to do was worry about the factors of 4. It was either 1 times 4 or it was 2 times 2. This one's kind of the same thing. Because once you've got the p over q and you've got everything set up, you have to go back and divide these numbers by these factors. So for this part, what happens when you divide anything by 1, though? It doesn't change anything, right? Still just those same numbers. So the factors, all the possible roots for this thing would be plus or minus 1, plus or minus 2, or plus or minus 4. And if they ask you just to list the roots, you're gonna have anywhere from 6 to 10, 12, might even have 20 different answers. But that's just all the answers it possibly could be. So this is telling us that x equals 3 is not a solution. X equals 5 is not a solution. You know, x equals 7 is not a solution. The only solutions we can have are 1, 2, and 4, positive or negative on those 2 possibles. All right, for example 2. Going to change that just a little bit. Let's make it 2x to the fourth minus x plus 6. And again, we're going to do p over q. And p is always the last number that's by itself. Q will always be the first number. And the biggest thing is make sure it's in descending order, so it's back in standard form like we were doing back in section 1. That it's written so you've got your highest power first, and then you just keep going in descending order from there. So it's the factors of 6 over the factors of 2. Okay, and there's only 2 ways to get 6. It's either 1 times 6. And again, leave more. Most of the time we do these, leave a little more room than you think, because there's most of the time, not all the time, but a lot of times there's one more set of numbers that you forget about when you're working through these, especially if you have a partner you're working with. You got 1 times 6. You also could have 2 times 3. And for the factors of 2, well, there's only one way to get 2. It's got to be 1 times 2. And again, it's some combination of positive and negative, and that's the part we don't know, because it could be that it's a negative 1 times a negative 2, or it could be a positive 1 times a positive 2. Okay, so there's your setup. Now, to get the answers, here's what we're going to do. We're going to take all these numbers and divide them by 1, like we did before. And if you divide all these numbers by 1, it doesn't change anything. So it's plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. And here's where we're going to go back to the factoring. Hopefully this is, and again, this is why we keep going back to the factoring. We're still kind of tying it back in again. If, let's just say this had been 2x squared. If that had been 2x squared minus x plus 6, we would have had to do them bottoms up, right? That if we would have gone back and multiplied 2 times 6 to get that out to be 12, we would have found the factors, and again, don't write this down, I'm just kind of setting this up. That would have been the factors of 12 that would have equaled negative 1. But it's x to the fourth, so we're not able to do that, but that's kind of the concept of what we're thinking. So for this one, because we're going to have to go back and do bottoms up, that let's say we'd found these factors, and let's say it had been 2 and 3, or 4 and 3. Actually, been reversed, right? It would have been a negative 4 and a positive 3. If it was x plus 3 and x minus 4, what was the one more thing we had to do here? Because in the beginning we multiplied by 2 to get these numbers. Well, in the end we have to go back and divide by 2. And that's where now we're going to do the same thing, that because we've got this 2 that's in front, we've got to go back and take all these numbers and divide them by 2. Because we might have to do bottoms up with those answers. So we're going to take all these same numbers and divide it by 2. So that means it's going to be plus or minus 1/2. If we do 2 divided by 2, that's 1. So that answer's here, so we don't have to rewrite that answer. We've got 3 divided by 2. That's not on the list. So we'll write that down. And then we've got 6 divided by 2, and that's 3. And we've got that 3 here. So that would be all the possible solutions that we're looking for. And you have to worry about the fractions with that first number, because technically we're doing bottoms up with that first number at some point in time if we're going to do factoring. So we don't know which part it could possibly be divided by 2, so we have to do the option that, okay, every factor could be divided by 2, because we're just trying to find anything that might possibly work for this thing. So find the factors of the last number, and you've got to take into consideration that you might have to do bottoms up, that you're going to have to go back and divide by 2. So we're going to take all these numbers and divide them by 2 and just see how many we have there. Alright, let me show you one more. Y'all want to try this one on your own, or is it too soon? Too soon, okay. Just got to ask and see. All right, hopefully one more to kind of sink in a little bit. All right, let's do 3x to the 5th plus 2x squared minus 12 equals 0. Again, we're going to set it up so we have p over q. And p is the last number, and q will be the first number. So it's the factors of 12, and if you put negative 12 in there, that's fine, over the factors of 3. All right, and again, just like you're doing before, you're going to list off all the pairs of numbers you can get to get 12. And again, leave more room than you think. You can do 1 times 12. You can do 2 times 6. And you can do 3 times 4. And again, because it's negative 12, it could be that it's negative 1 times positive 12, or it could be a positive 1 times a negative 12. So that's why we put the plus and minus, because again, we don't know where the sign is, but we know there's a sign in there somewhere. If it's negative 12, one's got to be positive, one's got to be negative. We just don't know which one it is. Okay, only factors of 3, that's going to be 1 times 3. Okay, so one of the numbers, basically we're dividing by 1, so again, first thing is we're going to take all the different options we have here and write down every single one of those numbers divided by 1, which means they're not going to change. So we've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And then the last thing you have to do again is that, because we're going to have to do, if we were factoring this like a normal quadratic, we would do 3 times 12 to get 36, and then at the end we'd have to go back and divide by 3 because it bottoms up. We're going to take all these possible answers and divide them by 3 because, again, they could be part of the bottoms up that's here. So then we've got 1 divided by 3. I'm just going to put that down here. Would be 1/3. Also could have 2 divided by 3. You've got 3 divided by 3, but that's 1, so we've got that covered here with the 3 over 3, so we don't have to rewrite it. 4 divided by 3. We've got 6 divided by 3, which is 2, so we've got that one covered here with the 2. And then you've got 12 divided by 3, which is 4. We've got that one covered there with that plus or minus 4. Okay, so those are all the possible answers we could have for this thing. And I know somebody's going, well, okay, that's great, but what do we do now? Because now we know all the answers it could be. What do we do with it? Well, here's what you're going to do. Once you've got this list of numbers, and again, depending on the numbers, like the very first example, we only had plus or minus 1, plus or minus 2, plus or minus 4. The smaller the numbers, the fewer options you're going to have. We made these a little bit bigger to 3 and 12. Well, now we've got 1, 2, 3, 4, 6, 12, 1/3, 2/3, and 4/3. So the bigger the numbers, the more options you're going to have. The good news is the numbers shouldn't go much past 12 because we don't want to do too many numbers. I mean, it's good to have a few options, but we're not going to make the numbers so big that you spend too much time doing it. So here's where we're going to tie it all together for today. Because those are the possible answers it could be. To find the actual answers, So this is everything that's possible. So now we're going to find the actual roots, or the actual solutions. You're going to take the possible solutions. And this is one where there's no other option other than this. Take the possible solutions and guess and check. To find a remainder equals 0. And you can do that using either synthetic division or 2. You're just going to take those numbers and evaluate it to see what you get. Now, in most cases, and it just depends on how comfortable you are with synthetic division, synthetic division is going to be your best bet, because when you've got it in synthetic division, the answer is going to be kind of laid out for you a little bit better than if you do evaluating, because evaluating, you're going to get the answer, but it's only going to give you one answer, and you've got to find 3, 4, maybe 5 answers. And doing that part, synthetic division is going to be your best bet, because it's going to have it set up so it's going to be easier to find the other answers, to have everything kind of rolling through it. Okay, so let's get the one problem down, we'll get everybody caught up, and then we'll walk through this thing together. First thing we're going to do is we're going to do the P over Q again. Again, P is our -6, and then the Q would equal 2. So it's the factors of -6 over the factors of 2. Now again, this one they ask you to find the actual roots, or the real solutions, but you still have to go through the possibles to get there. So to get 6, now there's only a couple options. It's either 1 times 6 or it's 2 times 3. Okay, and that's it. That's the only possible ways you can get to 6 with whole numbers. 1 times 6 or 2 times 3. 2, on the bottom, there's only one way. It's 1 times 2. And again, we don't know which one. It could be -1 times -2. It could be +1 times +2. So that's why we keep putting a plus or minus. Now, here's where it comes in with your friends, because we've got to get all the possible roots. So the first thing is we're going to divide everything by 1, which means it doesn't change anything. So it's plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. So there's all the possible whole numbers for the most part. We might get an occasional one that might sneak in. And then because it was multiplied by 2 in the beginning, if we're going to do factoring, you may have to divide by 2 at the end. So we're going to take all these same possible answers here and divide them by 2. So we've got plus or minus 1/2. We've got 2 divided by 2, which is 1, and again, we've got that one covered here, so we don't have to rewrite the 1. 3 divided by 2 is fraction, so we need to have that one in there. And 6 divided by 2 is 3, so that's covered here. So here's all the possible solutions. Or that's all the possible roots. Now, up till now, that's where we stopped. We said just list off all the possible roots to see what we're going to do. Here's all of our possible roots. Here's where it just comes down to guess and check. Now, on the next test, I would say probably the best thing to do is one of you do the positive, one of you do the negative, and start just guessing and checking with synthetic division. And the whole thing you're trying to do is you're trying to figure out which one of these numbers will give me a solution or a remainder in synthetic division that's going to be 0. All right, so now here's what I would say. Most people don't like fractions, so if you're going through this possible list of numbers, stay away from the fractions. Hardly ever, maybe one time in all the homework, you might actually have the biggest number on here be a solution. So I would say don't take the biggest number into consideration. Take it out. Pick your smallest numbers and go from there. And then just give me a guess. So what do we want to do? We want to do 1, 2, or 3? 2. We want to do positive or negative? Positive. Okay. So we're going to, we're just going to guess and check. So take a positive 2. And we're going to take that 2 and do synthetic division with the problem that's up here. Again, here's where you need to make sure your partner knows how to do synthetic division. Because if on the test, my suggestion is going to be 2 people working partners. We've got 30 people in here, so it's going to be nice, even groups. We've got 15 groups. One of you do the positives, the other one do the negatives. And just see what you get. It's in descending order, so we're good. So we've got a 2. That's a plus 1 for the x squared, a minus 7, and a minus 6. Pull the 2 down. And again, the whole guess and check is, does the remainder equal 0? That is the one thing we're looking for. If the remainder equals 0, that's what we want. If the remainder doesn't equal 0, we toss it out, we try it again. Okay, so starting with a 2. 2 times 2 is 4. 1 plus 4 is 5. 2 times 5 is 10. This one looks good. Negative 7 plus 10 is 3, because you can do 10 minus 7 to make it 3. And then 2 times 3 is 6. 6 minus 6? 0, right? And that's what we want. So if that's your remainder 0, we got lucky. Took a good guess. We've got the number we're looking for. So here's the first solution. Now, the good thing is, whatever number you plug in, that is a solution. So x equals 2 is one solution. And here's the next question. How many solutions are we looking for? And how do we know how many we're looking for? Anybody remember? What's the highest power term up there? 3. Guess how many answers we're looking for? 3. We've got to find 3 solutions. We've got 1. We've got to find 2 more. Now, if you're checking these with synthetic division, if one's doing positive and one's doing negative, and y'all find one at basically the same time, you've got 2 answers. You've got to find 1 more answer. Here's how you're going to find the other 2 answers, and this is why it's good if you do synthetic division. Everything before, when we were doing synthetic division back in section 4, we would take this answer and rewrite it, because this started off with x to the 3rd. This answer we would start with 2x squared plus 5x plus 3. And they would have you put remainder 0. But again, that's the big thing we're looking for, is that we want the remainder 0. In almost every case, there'll be occasional one where this won't work, and we'll show you this one tomorrow. Once you get this answer, when you found this solution, just factor this thing off. Yes?
So you have to use synthetic division, because I know on the homework it would be easier to just do regular.
You can do long division if you want to, but synthetic's going to be about 10 times faster. So if you want to make the test 10 times longer, you can do long division, but that's why we do synthetic, because it's almost, I'd say it's almost about 10 times faster than doing long division. So a problem you can do in 15 seconds with long division, with synthetic division, it's going to take you 3 minutes to do it with long division, probably. Maybe 2 minutes. So, all right, so once you're here, factor this thing off. Now, it's a little bit of a good news, bad news is they're all positive, but the first term is not x squared, it's 2x squared, so you're going to have to do the bottoms up. So we need to do 2 times 3 which is a positive 6. So we're looking for the factors of positive 6, where the sum is going to equal positive 5. So the good news is, again, they're all positive, which makes this one a little bit easier. So it's either positive 1 and positive 6, or it's positive 2 and positive 3. The ones that add up to 5, well, it's got to be 2 and 3. So that's x plus 2 and x plus 3. Now, again, back up here, I forgot to put that one. Technically, this thing is going to equal 0, so we still want these equal to 0. All right, but one more step, right? Because we had to multiply by 2 in the beginning to get this number, we've got to go back and divide by 2. We've got the 2 divided by 2, so that's 1. We've got the 3 over 2, which won't simplify. So we've got it here. Now, instead of doing bottoms up on that last step, once you've got it factored and you've simplified everything as much as you can, this is where you're going to set these equal to 0. The shortcut is just change the signs of these. So now you can tell me that x would equal negative 1 and x would equal negative 3 over 2. And we still have this first solution back here. So that was x equals 2. So there's your first solution that we found. There's the second solution, and there's your third solution.